Welcome back. So far, we made some excellent progress in learning Spark Streaming. We created a Spark Streaming application using the file source. File data sources are excellent in those scenarios where you collect data for some time and then you write them to a file. I mean, creating files of 10, 20 or 50 records is not advisable, right? Even if you look at the default block size of HDFS, it is 128 MB. And S3 block size is 32 MB. The point is straight. File data sources will make sense when you collect some reasonable amount of data and then you write it to a file. Collecting data and writing files might take a few minutes, isn't it? So, we often see the file data sources being used in a minute-based micro batches. If your use case can afford a few minutes of the trigger, then you can quickly implement your application using a file-based streaming source. However, a low latency stream processing requirements might not fit very well with the file-based sources. You might need to implement something that processes records more quickly and responds in seconds or less than a second. And there comes Apache Kafka. In this section, you will learn to work with Kafka as a streaming data source. Let's start. Do you remember the invoice flattening example? We are going to recreate the same example of flattening invoice items. However, this time I am assuming that the records are coming to Apache Kafka. So, your invoices are continuously coming to Apache Kafka. Now, you are asked to create a Spark structured streaming application that does the following. Read the data from Kafka topic, flatten the invoice records, and sync the outcome to a file system. Let's do it. Here is my initial template application. I have a main entry point and I also created a Spark session. We are now ready to start coding the 3 steps. However, before we start, let me highlight a critical requirement. Spark SQL and Kafka integration is offered by a separate package, Spark SQL Kafka. This package is available in the public Maven repository. Let me show you. So, here is the base repository of Apache Kafka. And here is the Kafka source for structured streaming. This package supports Kafka 0.10 and above. The current version of Apache Kafka is 2.6. However, the Kafka API structure is the same since 0.10 onwards. So, this package is good enough for us to use with any version of Apache Kafka above 0.10. If you scroll down, you will see one more package for Kafka integration. However, this package is for the older DStream based APIs, which we do not recommend to use in your applications. Now let's come back to the structured streaming package for the Kafka integration. As on date, this package is available for the latest version of Spark 3.0.0 and this package is built using Scala 2.12. So we should be using this one. Great. So how do we get this package to our Spark environment? Simple. Include it in your Spark defaults. Let me show you. Here is my Spark home. I'll go to the conf directory and open my sparkdefaults.conf. Here it is. I'm setting spark.jars.packages configuration and the value is the Maven coordinates of the required package. We have 3 parts to the coordinates that are separated by a colon. The first part is the group ID. The second one is the artifact ID. And the last one is the Spark version. Save this file and you are done. When we start our PySpark application, it will read this configuration and automatically download the required package and related dependencies from the Maven. Once downloaded, this package and other dependencies will be available to your application class path. If you want, you can also set this configuration from your application. Here is an example. This setting will also give you the same effect. However, we do not recommend setting dependencies from inside your application code. It is always advised to keep such things outside the main application code. So, we recommend to keep it in the Spark defaults. Great, that's all. You are all set to integrate your Spark streaming with Apache Kafka. Let's do it. We are going to create a data frame reading data from the Kafka source, right? We start with the Spark session and call the read stream to get a data stream reader. Then we set the format. What is the format? Any guess? Yes, it is Kafka. However, reading from Kafka requires you to provide connection details. I hope you already learned Kafka. If not, check out my Kafka course for beginners. So, the first option is the Kafka Bootstrap servers. You can give a comma-separated list of broker coordinates. But I'm running a single node Kafka cluster, so I'll be giving a single hostname and port. The Kafka source connector internally uses Kafka Consumer API, so the next most crucial thing is to subscribe to a Kafka topic. I want to read from the invoice topic, so I give the topic name as the invoice. What else? By default, the Kafka consumer reads from the latest offset. However, I want to change the starting offset as the earliest. This option makes sure we start reading from the beginning. However, you might be wondering with the following question. Will the second batch and third batch also read from the beginning? What if I stop the application and restart it again? Well, nothing to worry about. Spark maintains the current offset in the checkpoint. So, the starting offset is always overwritten from the checkpoint. The earliest will take effect only in case of the first run when your checkpoint is empty. Make sense? Great. So, we are done with the reading. What is next? The next step is to take this Kafka data frame and transform it as per the requirement. However, we have a catch here. Let me print the data frame schema and show you. So, the Kafka data frame always looks like this. We have a key and a value. Then you have other fields like topic name, partition number, message offset, and timestamp. Most of the time, you are only concerned with the key and the value fields. Other fields are used by the Spark Streaming Framework for creating the checkpoint. In this example, I expect a JSON invoice in the value field, and I do not care for the key. So, for me, it is the value field that I need to start with. However, I have a small problem. The value field is a binary type, and it is just a single field. Internally, it should contain a JSON data which looks something like this. This is one invoice. I can read it as a string by simply casting the value field to a string, right? However, I cannot apply a data frame transformation on this string unless I give it a proper schema. When I read the same invoice from a file, I could set the infer schema option, and the data frame that I got was a well-structured data frame with a meaningful schema. But in this Kafka data frame, I do not have a schema for my invoice. How do I fix it? Well, we can read the value field as JSON string and assign a schema to it. I'll show you in a minute. But before that, let me define a schema for the invoice. Here it is. I am using a struct type and struct field to model the invoice schema. I hope you already know this, and it does not require a separate explanation. After all, knowing Spark fundamentals is one of the prerequisites for this course, right? Great. So now we have a schema, and we want to assign this schema to the value field. Let's do it. I'll create a new data frame starting from the Kafka data frame. I'll use this select method to take only one column, the value, right? We are only concerned with the value field. However, the value is binary, so I should cast it to a string. I can safely cast it to a string because I know the value contains a JSON string, right? So now I should get a string. Assigning a schema to a JSON string is straightforward. Spark offers you a from JSON function to do it. So let me apply the from JSON function to the value string. This function takes two arguments. The first argument is the JSON string and the second argument is the schema. That's all. You will get a field that has a well-defined schema. Let's print the schema of this new data frame and see what do we get. So my new data frame has got a single field, and the field itself has got a proper invoice schema. However, the field name is little weird. We can fix it, right? Let's give an alias to the resulting column. Let me check it once again. Now it looks beautiful, isn't it? We came too far in fixing the Kafka record. Now I have a data frame of single column. The column itself is another data frame. So it is like a data frame of the data frame. The next step is to flatten it. Let's do it. I'm going to create another exploded data frame. Then I'm going to select value.invoice number. Then the created time and so on. Finally, we explode the invoice. The exploded data frame is the same as we created in the earlier example when we were reading data from the file, right? The rest of the code is the same as we have already written in the earlier example. I'm flattening the exploded data frame. Then I'm creating and starting a stream query. We are done. Do you want to run it? Let me show you. This example requires Kafka. So I have these scripts to start the Kafka server. You can run these scripts from your IDE, or you can copy the script content and run it from the command window. So we start Zookeeper. Then we begin the broker. Then I create the topic. Now we need to start sending some invoices to the Kafka, right? So let me start a console producer. Good. Now you can take a sample invoice and send it here. Let me do it. Good. Let me start the application. What do you expect? I should create an output file, right? Here it is. My invoice is flattened. You want to send some more? Let me do it. Wait for a minute and you can expect another file in the output directory. Looks like working, right? Let's stop it. In fact, I want to stop everything and clean it up thoroughly. I'm deleting the checkpoint, Kafka logs, and the output directory. I want to start over fresh. So let's start the Kafka once again. But this time, I'm not starting the producer. I got you something better. Let me start the Spark streaming application. It's running now, but it shouldn't be doing anything because we do not have invoices coming to the Kafka cluster. I got you a POS simulator jar. This is the example that I developed for my Kafka beginners course. This jar can continuously generate realistic invoices and send it to Kafka cluster. Here is the script to run the simulator application. It takes 3 arguments. The first argument is the topic name. The second one is the number of producer threads. I am using 1 thread, but you can give 2 or 3. The next argument is the pause in milliseconds between 2 invoices. So this simulator is going to send 1 invoice and pause for 1 second. Then send the next invoice. You can increase the speed by reducing the pause time or increasing the thread count. Let me run it. Great. So we started sending 1 invoice every second. Now you can go to the Spark UI and check what is happening. We already got 2 batches, right? Let's wait for a few minutes. Now we have 3 batches. And this will keep going on. You can come back and check the output directory. We have a bunch of files now. Each file is an outcome of invoices received in 1 minute window, right? That's all for this video. See you again. Keep learning and keep growing.